Okay, example 3 then. At time t, a particle has a position vector 4i plus 5j. The particle moves horizontally with constant velocity minus 3i plus 2j. Find the distance travelled after 5 seconds. Then you've got the point Q has position vector 6i plus 13j. Find the time when the particle is due west of Q. So start by doing part A, find the distance travelled. So we've got the initial position of the first particle, don't worry about Q yet, is 4i plus 5j. And the velocity is minus 3i plus 2j. Okay. Now if we want to find the distance, we should know that distance is speed times time, from the speed distance time triangle. And we want the distance after 5 seconds, so it asks us in the question. So all we can do is we can use this for our speed, so we can do minus 3i plus 2j times the time, which is 5 seconds from the question, which leaves us with minus 15i plus 10j. Okay, that's the answer to part A. Part B, let's just refresh our memory on that. Part B says the point Q has position vector this. Find the time when the particle is due west of Q. So for B, R of Q was 6i plus 13j. So they've done the work, the R equals RO plus VT for that one. Now we need to find that for the original particle. Maybe we'll call the original particle P. So if we work that one out, we'll have the initial position, which is this, plus the velocity times time. Expand that, collect up your i's, you get 4 minus 3ti plus 5 plus 2tj. So that's my position of P. Now, when they're due west, if you imagine what due west would look like, so say we had particle P here, oh sorry, it's the other way around, so when the particle is due west of Q, so it'd be P there, and maybe Q there. So if they do west of each other, it's like that, okay, because west is going to be that direction, isn't it, right? So, you know, north, east, south, west. If they do west, then we know that they're at the same position here. So this being the J components, their J components are the same. So if due west, J components the same. So they do west of each other, the J components must be the same. So what we can do is we can look at the J components of each of them, so 13 and 5 plus 2t, and equate those. So I'm going to equate my J's. And I get 13 is 5 plus 2t. So 2t is 8, so t is 4. So they do west each other at t is 4 seconds.